This is part 2 and continues directly from where part 1 left off. So if you've not seen part 1, this will make no sense. Get back to your class charts, find part 1 and watch that first. Question 20. All of the following are states of matter except, and I know you've all put putty for that. I know you all recognise solids, liquids and gases. 21. Water is different from other substances because, think about your solids, liquids and gases unit. Excuse me. For this question, we talked extensively in that unit about why ice cubes float on water. If something floats on water, it must be less dense than water. So ice cubes must be less dense than water. But ice cubes are made of water. So what does that tell us about the density of water as it starts to freeze, as it starts to become ice? Well, as water starts to become ice, it must become less dense. So therefore it can float. So it's less dense as a solid than as a liquid. So the option is B. Now that's unusual because most materials go the other way around. Most materials are more dense as a solid than they are as a liquid, as a gas. So water's unique in that aspect. 22. The melting point of water. The wording of this question may have caught some of you out because if they'd have said the melting point of ice, you've all said at 0 degrees C. I wonder if any of you have seen, scan that and saw the point of water and put 100 degrees, because quite often we do refer to the melting point of ice and the boiling point of water. So hopefully you didn't let that catch you out. The melting point of water, or the freezing point of the water, the same thing, is A, 0 degrees. 23, which is not a way that matter changes phase. When we talk about change in phase, we mean change in state. So going from a liquid to a gas, or a solid to a liquid. And the changes of state are going to be words like melting, freezing, boiling or evaporating, condensing, and we also learnt sublimation and deposition, or sublimation and desublimation. Mixing, D here, is not a change of state. We talked about mixtures in the unit. We can have sand, we can have salt, we can mix them together, but they're both going to remain a solid. They're not going to change state. So D is your answer there. 24, a substance that gets dissolved. So I'm making a mixture. Yeah, we used these terms in one of the videos last week. If I've got a beaker with some water in it and I add some salt, I know I'm going to make a solution if the salt dissolves in the water, which it will. But we described the water, the thing that's doing the dissolving, the liquid, we described that as a solvent, and we described the salt, the thing that was dissolving, as the solute. And that's what this question's asking. The substance that gets dissolved, so in other words, the salt or the sugar in the water, is the solute. 25. We've just answered in that last explanation. This does the dissolving, right? So what is it that dissolves the solid? All right, so water dissolving the sugar in our last example, we said that was a solvent. So 25 is D. And when it dissolves, it gives us our solution. And once we get to the point no more solid can dissolve, we have a saturated solution. Lots of words in that part of the mixtures topic. When we're talking about solutions, we have solute, we have solvent, we have saturated, all beginning with an S. So make sure you know the difference between those. 26. Water is an example of. Well, it's an example of a chemical, for sure. But it is also an example of a solvent because it will dissolve liquids. Sorry, it will dissolve sugar and salt. It is a liquid. So you could have put A or D for that question. Not a very well constructed question, I'll be honest with that one. So if you've put A, fine. If you've put D, that is also fine. It's not a mixture though. Water is H2O. The hydrogen and the oxygen are chemically combined together, which means it can't be a mixture. It has to be a compound. And it's not a solute because a solute is a thing that dissolves in the water. So you could have had A or D for that one. 27. Solutes dissolve faster. The answer here is at higher temperatures, but here's why. When I take my salt and I pour it into my water, right? I take my solute and I pour it into the solvent. The liquid particles, the way they are arranged in a random pattern, even though they're all touching each other, the pattern creates gaps, and the salt will go into those gaps. Now, when I increase the temperature, the particles are moving around faster, and we get the creation of more gaps and bigger gaps, and that's where the solute tends to hide. So at higher temperatures, we can dissolve more of the solute. That's for 27. Right, 28. Something is the largest amount of solute that can dissolve in a specific amount of solvent. So the answer here is solubility, and solubility describes to us how good something is at dissolving. How much solute can I dissolve in a specific liquid, a specific solvent? That's solubility. 29. The amount of a particular substance in a given quantity. Concentration. So if I wanted to make, for example, orange cordial, you know just from everyday sort of language, not even science lessons, that if you want it to be very dilute, you put more water in. If you want it to be very concentrated, you put less water in and more of the orange cordial itself. So if I have a solution that has more solute, right, so maybe water and salt, if I've got a solution that's got more salt than another one, we say it's going to be more concentrated than that. Than the other solution. If I've got a solution that's got way more water in, it's going to be more dilute. So concentration describes the amount of the substance that was dissolved in our solvent. It describes the amount of salt in the water. So that's our answer for that. 29 is B, concentration. 30. A something solution contains the maximum amount of solute. We've used this word already in the past few minutes. What word beginning with S describes a solution that has the maximum amount of solute dissolved? All those gaps are filled. No more solute can get inside. We use the term saturated for A. If it's got the maximum amount, it's a saturated solution. Question 31. A solution that contains a small amount of solute. So in other words, a solution in which I can add more solute. Maybe a salt solution, salt in water, but I can still add more salt. It's not yet been saturated. Well, our answer to that is D, unsaturated. Yeah, it's not yet been saturated. Question 32. This time we're talking about a solution that has too much solute. So it's saturated, but we've carried on adding more salt, for example. The term for that is supersaturated. So if I take some water and I add some salt to the point where the salt will no longer dissolve, so it's now saturated, and I continue to add more salt, it's going to be a supersaturated solution. Question 33. Lemonade, sodas, salt waters are all examples of what? Well, they're all examples of liquids that have inside them a dissolved gas. The carbon dioxide that goes into those fizzy drinks, when you open the top and it all comes out as bubbles, it's coming out of solution. It's dissolved inside the liquid and it's coming out of that dissolved state. So they are solutions. That's the answer to question 33. The gas is actually dissolved inside them. And the reason they need a lid is because carbon dioxide isn't really a very soluble gas, and to dissolve as much as you need to make pop fizzy, you need very, very high pressures. So the lid has to be on, it's pressurized inside that bottle, and as soon as you release that pressure, you make the pressure on the inside of the bottle now the same as the atmosphere. A lot of that carbon dioxide can come out. Okay, question 34 this time. An example of a suspension where the mixtures separate, which is what we've said a suspension is. We have these four options here, and hopefully you've circled option D, which is B and C. Okay, oil and water definitely separate. We mix those two together, we get the layer of water on the bottom, the layer of oil on the top. And flour and water, although it can take quite a while with flour and water if it's really well mixed, but given time the flour will settle to the bottom. So the answer is D for those. Question 35. Not a sign of a physical change. So a physical change, remember, is where we go from a solid to a liquid, or a liquid to a gas, or in reverse, any of those. So in a physical change, the texture will change. The texture of ice is very different to the texture of water. The hardness will change. The bubbles, well, if I'm going from water to a gas, I'm going to be doing a change of state or a physical change. And I'm going to see bubbles if I'm boiling the water. The only one of those that isn't a sign of a physical change is B, the odour, the smell. Question 6. Which of these will cause a solid to dissolve faster in a liquid? Well, if I want a solid to dissolve faster in a liquid, I need to do, well, I could do a few things. We've already talked about heating it, so the particles move around faster, so we have bigger gaps, more space for the solid to dissolve into. But what we also could do is option B. We could stir the solution. You see, if I've got lots of salt that's just lying at the bottom of my beaker, the gaps in the water at the top, then how is that salt going to dissolve inside those gaps? I'm going to stir it or agitate it, might be the term that you pick up more when you get to GCSE. Question 37. When I increase the temperature, what happens to solubility? All right, so as I increase the temperature, what happens to the amount of solid I can dissolve? Well, we've already said that when we increase the temperature, there's more movement, we create more gaps, bigger gaps, so more things can be dissolved. So the answer is D, the solubility increases. So warm water, and you can try this yourself at home, warm water will dissolve more salt than cold water. So question 38, which of the following is not a factor which affects the dissolving of solids? Well, we know that particle size is. The particle size relative to the size of the gaps in the liquid is going to be a big factor into how much can dissolve. We know that temperature is. That's going to affect the size of the gaps and the number of gaps. We know that movement is. Agitation or stirring. Thickness there really is our answer. It doesn't really have anything to do with the topic at hand. Just a bit of a red herring. Now, they are your answers. Hopefully you've picked up something from that. You should also find this in your class charts. This is going to help you just with your revision of the properties of metals and non-metals before we get on to the chemical reactions video next week, which will complete the topic. We have on our first sheet the properties, and on the two sheets below we have metals and non-metals with our gaps, and it's literally just a case of creating your mind map by adding them to the relevant sheet. What I'd also like you to do is get onto Google and have a look at other properties of metals and non-metals and add them to the sheet with particular examples of the metal or non-metal that you're talking about. So that should be, I mean, this has been a long video. That should be plenty for you for today. And on Monday, I'll be back with the final video for this topic before we start revising for your assessment, which is coming soon. Thank you.